correct. So there were some equalities are given in option A. 0 1 whole star intersection 1 0 whole star is equal to pi. It is wrong because there is a common string epsilon. 0 1 whole star contains epsilon, 1 0 whole star also contains epsilon. So it cannot be equal to pi. Option B, a plus b plus c whole star is equal to a star b star c star plus a star b star plus c star plus c star a star b star. So here this will be generally all combinations of a's and b's and c's. If you want CAB or CBAA, that we can't get from this. Okay, so for example CBACBA, this type of strings are not allowed in this, but it is allowed here. So both are not equal. So option A is wrong, B is wrong. C is a plus b whole star a plus a plus b whole star b plus epsilon. That means all strings end with a union all strings end with b plus epsilon. That is all combinations of a's and b's. That is equal to a star b star whole star. Option C is right. D is a plus b whole star intersection a plus b whole star ab is not equal to a plus b whole star ab. It is equal because a plus b whole star ab is a subset of a plus b whole star. So this is also wrong. Option C is the right option here. So for this question, option C is the right option.
Match the following statements with true T or false F. Here 4 statements are given and we need to identify which of them are true and which of them are false. If you see first statement, all CFG is equal to G is such that G is a CFG and L of G is equal to sigma star is undecidable. S2 is given as A is equal to G. G is a CFG over 0, 1 whole star 1 star intersection L of G is equal to phi is undecidable. S3 is CFG G dash such that G and G dash are CFGs and L of G is equal to L of G dash is undecidable. S3 is true. Why? Because in case of CFGs there is no particular algorithm in order to prove that those two CFGs are equal. So that is undecidable. If you see fourth statement, G such that G is a CFG and L of G is equal to phi is decidable. Yes, this is also true. Why? Because for a given CFG we can find out that L of G, the language accepted by that particular CFG is decidable or not. For this we construct a CNF grammar, and from that CNF grammar we draw a precedence graph, and with the help of precedence graph we can find if the language accepted by that particular grammar is empty or infinite or finite. So that problem is decidable. So these two are S3 and S4 are true. If you see first statement, G is a CFG and L of G is equal to sigma star is undecidable. Even this is also true. Why? Because for a given CFG, the language accepted by this CFG is equal to sigma star. In order to check that the language accepted by that particular CFG is equal to sigma star, there is no particular algorithm. So statement S1 is also true. If you see second statement, G is a CFG over 0, 1 whole star, and 1 star intersection L of G is equal to 1 star intersection L of G is phi. Here this is here G CFLs are closed under intersection with regular sets. Here 1 star is a regular set, and this is CFG as G is a CFG, L of G is CFL. So 1 star, that is regular, intersection CFL is a CFL. Why? Because CFLs are closed under intersection with regular sets. So this will come to CFG. These two terms will reduce to CFLs, and then H2 will be equivalent to S4. For a given CFG, we can show that if it accepts empty language or not. with the help of precedence graph. So this is decidable, but statement is given as this as undecidable. So we can say that statement S2 is false. So here given options are option A S1 true, S2 false, S3 true, S4 true. Option B S1 true, S2 true, S3 true, S4 true. Option C S1F, S2F, S3T, S4T. So option D S1F, S2T, S3T, S4T. So your correct option is except statement 2, all the given statements are true. So A is the correct answer. Which of the following statement is true? A. Option A. Every LR0 grammar is also SLR1. An ambiguous grammar can never be LR grammar. Every LL1 grammar is also an LALR1 grammar. Option D. All of these. Every LR0 grammar is also SLR1 grammar. This is true. Why? Because if a grammar is LR0, then it is also SLR1 grammar. LR0 grammars. These are LR0 grammars. This is SLR1 grammars. These are LALR. This is LALR. So that CLR1. These are unambiguous grammars. Unambiguous grammars, CLR1 grammars, LALR1, SLR1 and LR0. And these are LL1 grammars. And these are ambiguous grammars. And these are operator grammars. So with the help of this diagram, we can answer this question. If you see option A, every LR0 grammar is also SLR1. If you see the diagram, these are LR0 grammars, and these are SLR1 grammars. So we can say every LR0 grammar is also SLR1 grammar. Option B, an ambiguous grammar can never be LR0. Even this is also true. LR parsers cannot parse ambiguous grammars. That means an ambiguous grammar can never be LR grammar. So option B is also true. Option C, every LL1 grammar is also an LALR1 grammar. With the if you see the diagram, we can say that every LL1 grammar is also LALR1 grammar. There are some grammars which are not LR0 but LL1. But every LL1 grammar is also LALR1. So option C is also true. So here correct option is option D. All of these. All the given statements are